Hello, good evening to this live session. Quite delighted to catch up with you live today. It is the live session on the non-conventional energy sources course. As most of you are aware, we are doing these live sessions across a variety of courses. In fact, all the courses that are presently running on the NPTEL site. It's a good opportunity for all of us, both students and faculty, to interact live. Because that's an element that's sometimes not easy to come by in the scheme of online learning. So we're very happy to do this, and I'm happy to be here. So please feel free to send in your questions. I can see questions coming up. There are some questions from before. So let me just start off with something which would be very nice. I think a nice point here. I think there was a question from Vedant Sharma. So he wants to know, he says, as we know, there will be great scope for non-conventional sources of energy in the future. So we as the students, if we wish to start our business in this field, where should we start from and what will be the opportunities and challenges in this field? So I think I quite agree that, non-conventional sources of energy represent a very significant fraction of business opportunities out there. For example, I think I would say, but in this you can see there are a wide range of technologies. There's different levels of maturity of the technology, different levels of cost aspects associated with the technology. So I think at present, maybe the two technologies that really stand out are, I think, the wind turbines and to some degree the solar panels. Solar panels are still a bit on the pricey side, so I'm not really sure that we will have large-scale deployment of solar panels, across the nation kind of thing, across the world. But I think still it's a good business to get into if that is something, if you're interested in starting a business in this area. Maybe it is less resource intensive initially, or maybe you need less capital money to get started with your business in solar panels. If you want to get into wind energy, you probably need much more of an industrial setup. You would need something more significant in terms of, because you need to have towers, you need to have installed towers in which you're going to build. So you will need a much more, industrial approach to dealing with wind turbines for you to actually put it up. But solar panels may be much easier to get going. So those are two technologies that I think are of great interest. There are a lot of battery companies out there. So if you are starting some business associated with batteries, that is actually, again, reasonably mature technology. So maybe those are the three technologies that I would say you should look at, and then start from there. Maybe we'll. So I will hold that answer there. Maybe if necessary, we can get back to that question based on any other query we get. Of course, a lot of queries on the exam pattern. Yes, it is going to be an online exam. So an online exam would typically mean the questions are, something that you can do multiple choice on or fill in the blanks with some. I may still give you some problems to solve, but there will be things that you can answer with a number, and then the number is within a range, you get the marks for it. So it is not going to be pen and paper. It is not going to be descriptive. It's not going to be long answers or any such thing. It is going to be objective type of some nature, which you can answer with the computer. So, but it's not that there won't be any calculations. So there's this ongoing question on wind turbines and noise pollution. So, like I said, locally, a lot of people object to the presence of wind turbines because of the repeated noise. So that's one thing. I also want to tell you that, being students, you probably have, great attachment to every mark that you get or every half mark that you get. But I would suggest that you look at the assignments in a little broader context. Don't worry about every half mark, 1 mark. Please remember, we're going to take the best 8 out of 12 assignments. So your best 8 assignments we're going to take, and that is going to account for only 25% of the mark. So we need to put that in a bit of a perspective. So if you are, worked up about one question, you should really reconsider whether that's really a reasonable thing to do. So don't worry about it. Just enjoy the course, answer. I mean, unless you see major errors in several questions or something, don't get too worked up about it. And I don't think that's going to be the case. At most, you may have some, finer aspect of some one question that you are not completely in agreement with respect to what answer I've given. So that's what I want to tell you in that context. Let me just see what else we have here. So once again, good evening to a lot of you. I think many of you are joining in now. Let me see what else you have here in terms of questions. There's some question on, will roads be able to generate power by any technology? I know people are working on pressure on the road in terms of vehicle passing by that and then generating some energy from that. Looking at even it is already there, so you can, if there's some way in which you can collect solar energy through it. Those are all options you can look at. I don't think there's any proven thing that is sitting out there which can be tried. Yeah, so there's a question on how we can purify water by photocatalysis. I think I've shown you in the class the idea that you can actually have a secondary reaction going on there in the form of a sacrificial agent, where something else in our class, I think we spoke about glycerol getting oxidized. But glycerol, in that case, we have specifically added glycerol and done the oxidation. But you can also have any other species there which can get oxidized. And so in that process, if it's an impurity, you can clean it up. So that is the thing. There are a lot of questions about AKTU. I mean, if you're interested in an NPTEL certificate, you would have to take the NPTEL exam. If you're primarily interested in the credit transfer to AKTU, so you have to check with AKTU what is the exam process they are going to do that. Okay, that's the thing. So here's another question we have from Pranav. Pranav has a question on how come solar cells work if only the N side receives all the sunlight, as shown in the lecture. Very good question. I may have mentioned in the class, sorry if I missed mentioning it in the class, but this is a very good question. I think I did mention it in the class that the N side will have to, the side that faces the sun will have to be necessarily thin enough that the sunlight can penetrate through it and reach the other side, side of the PN junction. So if it is, in fact, if it is, you're absolutely right. If you make the N side thick, then the sunlight will not penetrate the N side, and then it will not reach the junction, and then the junction will not work. So the solar cell, the side that is on top has to be thick. Only then it is going to work. So that's very important, and very happy that when you caught that specific point about how that would work. Okay, so here's a question. Again, I don't know if I mentioned this in the class from. So I'm not sure why he's asked this question here, but anyway, on how people in ancient days used to protect their eyes from snow reflection, like modern people use goggles. Maybe I said something in relation to this in the solar energy part of it. In olden days, in fact, if you look at, I mean, I don't know, sketches of people from olden days or pictures of people from olden days, so they would just simply have a band that goes around their eye, or a piece of wood that goes around their eye with thin slits. So with the slit being thin, less light will come. So just it's like looking through a tiny hole. So if you just cover your eye and you look through it, you'll find you'll be able to see, but it'll look very dim, relatively dim, and that's basically the thing that was done. Yeah, so there's a question on, can you explain the case of wind fully stopped by windmill? Utsav Bharadwaj wants to know that. The idea there actually in that context is simply that we are looking at the options that are available to us. So wind arrives at a windmill, so you look at the option that a wind is completely stopped by the windmill or goes past the windmill without any interaction with the windmill. So those are like the two extremes of what can happen when wind arrives at a windmill. So that's basically the idea here. So when wind is fully stopped by the windmill, it's the same as saying you just put a piece of cardboard or a piece of flat piece at which the wind comes and then hits that piece and halts, right? So that means the wind is not going further. So technically what that means is all the energy that was available in the wind got transferred to that, whatever was that obstruction. That obstruction absorbed that energy, right? So that's what the meaning is in saying that you had this obstruction and you had this wind come and hit that obstruction and halt. Now, that's great news because it means all the energy now got transferred to this object, and so potentially you can, tap the entire energy. But reality is that, it is going to cause a problem, because if a certain volume of air arrives at a location and it is completely stopped, that means that air is not moving. At this point, the air has come and halted. So if this is the obstruction and the air has come and halted here, this volume is now filled with the air that arrived, and the air is parked there. It is not going anywhere. So what does this mean? So this means at, say, time equal to 0, you start this experiment, wind comes, it hits this obstruction, comes to a full halt. Now, no further wind can come and reach this obstruction. Let's say this is your windmill. No further wind can come and reach this windmill, because in between there is this previously stopped air is parked there. So unless that moves away, unless that moves past the obstruction, you're not going to have any fresh air come here. So that means the ability to completely 100% capture the energy available in air can be done only for a fraction of a second, instantaneously. The moment you accomplish it, from there on, you will get zero energy, because no further wind will reach that point. So that's the idea there. So what is the other question? So Swapna wants to know if there will be anything related to nanotechnology. So not in this course. We may come up with another course on nanotechnology. In this course, we only briefly touch on nanotechnology in the context of solar panels, where I mentioned the idea that you can change band gaps using nanotechnology. So, but other than that, we are not seriously getting into nanotechnology in the context of this course. Yes, so Ujjwal Singh wants to know, can we replace water heater in place of solar? Can we replace water heater with a solar flat plate collector? Yes, I think, in fact, if you go to many cities, I think, for example, at least I am aware of in Bangalore, every new building has to have a solar water heater. It's a requirement there. And they are basically using it for hot water for their bathroom or any other application, because it can get relatively cold there, at least relative to Chennai. So yes, we can do it, and it would be nice to do it. So that was a question. Let me see if there's anything else here. That is. Okay, so I'll just glance through these questions that that you have sent here. Okay, so there's this question on biomass. Is it renewable, non-renewable? Because it involves burning of wood, and I think different people have asked about this. The issue with biomass is that basically if you burn a tree, okay, so that's the idea here, you're burning a tree. Of course, you can regrow the tree. So therefore, that is considered renewable. You can always plant some seed, water it, and get the plant back. And the only problem is that the only problem is that you can burn a tree in a matter of, I don't know, based on how you go about burning the tree. You can burn it in half an hour, you can burn it in 1 hour, maybe even burn it down in a few minutes. If you're using it for, if you supply it as a material that is going to be used in some thermal plant, you can actually burn the tree down in 5 minutes or something like that. But it is going to take you years to grow the tree back, right? So it is going to take you some maybe 5 years, 10 years for you to get a tree of similar stature back. So, so this idea that it is renewable and that it is non-polluting. So what people say is, because this tree has come back, it has pulled back the carbon dioxide. So when first you burn a tree, so the tree contains so much carbon. Let's say it contains 1 ton of carbon. So in terms of carbon atoms, let's say it contains 1 million carbon atoms. It will have way more than 1 million carbon atoms. But just for some number to work with, let's say a tree has 1 million carbon atoms. So you burn it. That now you have 1 million molecules of carbon dioxide. So if you regrow the tree, and comes back to the same size, then it has pulled back that much carbon from the atmosphere again. Okay, so same 1 million atoms of carbon will come back into the tree. So that way you have not added any new carbon dioxide to the atmosphere. So that's the idea with which they keep saying that the biomass is a renewable form of energy and it's a clean form of energy, kind of. Now the issue only is that you can put this carbon dioxide out into the atmosphere in 5 minutes, but it will take you some 10 years to pull it back. So what is happening in that 10 years? In that 10 years, you have in that time frame, you have a huge amount of carbon dioxide out there, which is much more than you have pulled back. So in terms of time scale, if you want to make a difference to the environment, like we said, we are at a situation where we can double the amount of carbon dioxide in less than 100 years. So if you're trying to fight that, it is very important that the rate at which you pull carbon dioxide off the atmosphere should at least match the rate at which you're putting the carbon dioxide out, or ideally should be even faster than that rate. Only then you're going to improve or clean up the atmosphere. So in that context, biomass is not a great idea to pursue, is the feeling that I feel. So there is a question on from Ujjwal Singh on how we define practical efficiency obtained by wind as 10 to 30%. That's just the practical efficiency, which means that's the efficiency that many companies that make windmills actually, what shall I say, measure on the ground. On the ground, they put out a turbine capable of collecting some amount of energy. What they actually find based on the size of the turbine, they can calculate what power is available in the wind at that point. And based on what they actually capture, the amount of energy that they pick up is only about 10 to 30%. So that is how we are looking at the practical side of wind energy. Okay, can we use Shalvak Singh has a question on, can we use geothermal energy other than to generate electricity, like cooking or other heating purposes on a large scale? Yes, in principle, yes, it can be done. It is just not convenient to see. The thing with the heat is you want to use the heat before it is lost. So now, if you are transporting it over long distances, you will lose heat very fast. So unless you transport it in a exceptionally insulated manner, you're going to lose the heat very fast. So it is possible for you to use this heat only very locally. You may not be able to use it over long distances. You can't really supply hot water for several hundreds of kilometers. It's not going to happen. So that is the problem with this. Okay, so let's see. Okay, what is the other question we have here? There's a question on what will be used more in future, electric cars or cars working on hydrogen fuel cell, and which one is more economical or efficient? This is from Dhruv Sharma. So let me put it this way. A few years back, say 20 years ago, 10 to 20 years ago, people really felt fuel cell cars would be the wave of the future. On the ground, however, what has happened is battery-powered cars have caught on more effectively at the moment. So some of the more successful electric cars, both are electric, the more successful deployment of electric cars has happened using batteries. So for example, the Tesla car, which is the more famous or popular electric car that is out there, or the range of Tesla cars that are out there, are all based on lithium batteries. But at the same time, many manufacturers are working with fuel cell cars. They're trying to see if they can get that to be a workable technology in a much more elegant manner or comfortable manner. And we never know. I mean, sometime down the road, that might very well become a more successful technology, or both technologies may exist. I mean, side by side, we may have some number of battery vehicles, some number of fuel cell powered vehicles, some number of combo vehicles, which may have both of them running on it. So that is the status of these technologies. Okay. Okay, so Utsav Bharadwaj has a question on why does the power become constant after the rated velocity in case of windmill? So in windmill, I think the basic thing is that we try to ensure that the uh, that the wind turbine is safe. We don't want to get the wind turbine destroyed. These are infrastructural investments that we want to last for a very long period of time. So therefore, if it has a range of velocities over which it is safe to operate the windmill, we try to ensure that we don't exceed those velocities. But that is not really in our control because the wind is whatever comes from nature. So if there is a storm of some nature and wind speeds are going to exceed 70 or 80 kilometers an hour, then we try to shut down the windmill or try to protect the windmill. So normally there's only a certain range of velocities over which it is allowed to operate, and we don't allow it to go faster than that. And therefore, based on that, the power, since we're not allowing it to go faster than that, the power levels up. So that is the. So there's a question here from two questions. Vijay Kumar wants to know on the difference between lithium-ion battery and zinc-air batteries. I think we will touch upon it towards one of our later classes. Basically, the chemistry is different, so the chemicals you use is different. So what oxidation reaction occurs and what reduction reaction occurs are different. That's fundamentally the difference between all batteries. You have a wide range of batteries. Exactly what chemical reaction is going on or electrochemical reaction is going on with the battery is what is different between them. Otherwise, fundamentally, the principle is the same. Ravi Pal wants to know which ministry is mainly responsible for research and development in renewable energy sources such as wind power, small hydro, biogas, and solar energy. So there is a ministry called MNRE, Ministry for New and Renewable Energy. So they cover a large spectrum of what you are looking at. So that is they are probably the main ministry that you should look towards if you're looking at something in this nature. Ujjwal Singh wants to know, can we make the blade of the windmill with wood? The older windmills were made out of wood. Today, the design of the blade is very sophisticated because it has this aerofoil kind of shape, and they are very large blades. So the natural materials we get, including wood, will have difficulty in being able to maintain this shape in a structurally safe manner. So quite often we end up using more composite materials, which are easier to work with and maybe made in a with less weight but sufficient strength. So that is the thing. So like I said, so the more powerful windmills, the windmills which are making more, which are used for larger scale power generation, are usually not made out of wood. But you can make smaller windmills out of wood. There's nothing that prevents you from doing it. So that's the aspect there. Umesh wants to know about using piezoelectric cells on highways. Yes, you can do it. I don't know cost-wise if that is effective, but in principle, yes, you can use piezoelectric materials on highways. There's some question on tidal energy. I think again we'll deal with it in one of our upcoming classes. We'll see it. Let's just quickly see here. Other questions we have. Take a quick look at what other questions we have. There's something on transmission losses. So we had a question from, again, Pranav, I think, on is it also important to find an alternative for transmission losses of electricity? So yes, it is. I'm not really sure what's the answer to it because transmission losses are significant and they relate to basically IR losses on the in the wires, and so there may be no easy solution to it. People use high voltages to deal with it, but that is not. I mean, that will reduce the problem, but never makes it zero. So that's the issue there. Okay. Ujjwal Singh wants to know any project we made by NCR in final year. I'm not sure what you're referring to. I mean, of course, sure, you can do projects in non-conventional energy resources, but that will depend on your college and what facilities you have there or what options you have available for doing it. There's a question from Tanzeen on temperature deep inside the ocean. Is it relatively unchanged by time of the day? Yes, deep inside the ocean is relatively unchanged by the time of the day. So okay, so let's just see if what is the approximate cost required to set up electric power station for cars? Stress, I'm not sure because this is still coming up. I'm assuming you're talking about recharging stations for cars so that they can come and get charged while they're parked. I don't think it is going to be that expensive. It's more about the electricity being made available there and used. So NCER carrier scopes. Yes, there is a lot of carrier scope if you work with non-conventional energy resources, but you have to understand that today, like with all the other fields, it is not sufficient at all for you to just say that I have a degree in something. Okay, so it's not at all going to be sufficient. You have to show that you are actually good at something. So a degree simply says that you went through some formalities, you did some courses, and you passed the courses. You yourselves know amongst your friends there will be some who study very well, some who don't study at all, some who get good marks, some pass the top of the class, some pass at the bottom of the class. Lots of stuff. The full range of people are there. So you have to show that you're really good at something. And part of that is doing well in your courses. It is also about having a good feel for that field, remembering things, doing it, doing experiments, whatever. So there is always career scope in NCR, but you have to show yourself to be good at something, and then that will help you get a good job. There are a lot of battery companies out there. Like I said, there are a lot of solar cell companies out there. There are a lot of wind energy companies out there. So a wide range of options are available to you, but you have to come across as somebody who is very well prepared to come to that job and perform at the job. So then that is useful. So that is something that you want to look at. So desalination of seawater. How does desalination of seawater take place? As stated in lecture. So we will touch upon it. I think in the class itself we will touch upon it. We will see at that point, or maybe I can add something more to it at that point. What is the work of mentor in NCER course? Okay, so mentor is something that is a general concept that is used in all the NPTEL courses. It is typically a faculty in your college. So if you are, so this is relevant only if you are a student from a college and you are registering through the college, like you indicate that you are associated with that local chapter. Then the mentor is in a better. Then there will be some mentors from who are typically faculty in your college, who offer to be mentors for the course. They will get access to some details of all the students from the college who are submitting answers and whatnot. And if you're facing some difficulty, they will be able to either directly assist you or work with us to help assist you. Let's see here. Okay, Vijay wants to know, is there any subsidy for setting up of wind or solar plant? I'm not sure if it is there right now. I know for a long time to set up solar installation in your house itself, there used to be a subsidy. But I do remember people telling me that even though officially it is there, it's sometimes a bit difficult to actually get the subsidy to you. So that issue is there, but I think there is some I mean, some possibilities are there. So let's see here. Okay, so there's a question here on how can we measure the amount of electricity consumption in our home and buy a solar panel to suit our needs? So actually, this is a fairly, I would say in some sense, I mean, this is a valid question, no doubt, but it's also a fairly straightforward question to think about, because already in your house we have I mean, your electricity meter is there, so you actually have a lot of data being collected in terms of how much electricity is being consumed in your house. Typically, you can even get fairly detailed information on how much electricity is being used in your house. You should, I'm sure there are small electronic circuits which are either commercially available, or maybe the electricity board itself will be able to supply this, which tells you the consumption not just for a month, but an hour by hour consumption, or a continuous. You can get a graph, so which will say, so typically, for example, in most homes, if you take, you will see that morning people get up and then everybody is doing various things. There's some cooking going on. There is some people are getting ready. So hot water is being made. A lot of things are happening. So usually there's say between 6 and 9, there's considerable use of energy. Maybe if it's all electric, you see a lot of electricity usage. Then by about 9, most people have, if children are there, they have headed off to school. People who are working are headed off to work, and so on. And whatever cooking and other activities that had to be done in the house sort of winds down. So then from 9 till, for most part of the day, till about 5 o'clock or something, 5 or 6, everything remains quiet. You don't really, you see very low electricity consumption. Then again, evening around 5, 6, when people come home, and from there till say 8 or 9, where people are active, watching TV, using, cooking, eating, doing various things at home, using the computer, etc. at home, you see an increase in electricity usage. Then past 9, 10, something around that time, when people go to bed, again, most of the rooms, lights are off, fans are off, everything shuts down. So you just have 1 or 2 rooms where the lights and fan, where typically only the fan is running. So again, power consumption comes down. So your average power consumption is itself not enough. You need to know this kind of detail of how the power varies, how power usage varies through the day, for you to figure out how to use, say, solar panels to assist you. So because solar panels are there in wide range of sizes, wide range of capacities. So what capacity should you get so that it helps you handle this kind of power usage? So, so people usually use solar panels along with batteries so that you can manage this load. So if the load is high, it doesn't help if you have a solar panel that meets the full maximum load, because then what will you do with that power the rest of the day? So it's kind of wasted. So you have to size it right so that you can actually use it in the house, in conjunction with the house. On the other hand, if you have a situation where the electricity can be supplied to the grid, then you can have a large solar panel. You can supply excess electricity to the grid, and then you can even get some money for it. You can actually get a discount on your bill, etc. Okay, so that's the idea there. So we have Utsav Bharadwaj, who wants to know, why did the cathode in the electrochemical cell require access to water? Okay, so I'm assuming this is with respect to the electrolytic splitting of water. So for the splitting of water, you need to have the reaction occurring, and therefore the electrodes need to have access to the material that is reacting. And therefore, if water has to be electrolyzed, both the electrodes need to have access to water. That's basically the idea there. So Ashish Sharma says, sir, we are not looking for solar energy running trains. So it is likely that if you just take a train, so train may need a lot of energy to run because of the weight of it. But of course, that's again a technology a lot of people are working on to make I mean, what shall I say, train run. So there's a lot of work going on trying to make the train lighter. So that itself is there. But over and above that, you can certainly put solar panels on trains. It is not that you cannot put solar panels on train. My guess is that it probably doesn't have, because there's only so much surface area on the train, right? So on that surface area, typically the top of the train is the roof of the train is what is continuously exposed to the solar energy. If you're if you look at the left side or the right side of the train, then depending on which side the sun is, it may get sunlight, it may not get sunlight. Even if the sun is directly above, the two sides will not get sunlight. So relatively speaking. So mostly you're looking at the top surface of the train capturing solar energy. So there's not a lot of area there. I mean, for the weight of the train, you're not going to capture a huge amount of energy from just the roof. But you can certainly use solar panels on trains to cover all the other, convenience kind of electricity. So all the lighting, the fans, maybe even the air conditioning can be covered by that, and then you can use less for the train itself. So yes, in fact, now he says, can we use semi-solar train? Yes, indeed, Ashish is right. I think you can use what you might describe as a semi-solar train. Okay, so that is the thing. And okay, how can a solid electrolyte transport protons and water in case of hydrolysis? So it basically depends on the electrolyte. So the electrolyte is a protonic conductor, then you will be able to transfer, energy through the ions through that electrolyte. So that's a fundamental property of the electrolyte, and that is how that would work. Okay, so. Okay, Nandakumar wants to know, is wireless power transfer possible? Well, to some degree, it is already going on today. I mean, you can see all this wireless charging that is being made possible for mobile phones and so on. So people may be working on it. I'm not really sure how successful it will be in long distance transfer of energy. But for short distances, very close proximity, it is possible to transfer energy in a wireless manner, and so that is how it comes. So Ujjwal Singh wants to know something about 16 by 27 equals 0.59. What is value 16 and 27? So you have to look at the derivation. This is from the Betz limit. If you look at the derivation, we will arrive at that ratio 16 by 27, and that's basically the what should I say, the maximum efficiency you can get using a wind turbine, and therefore you will, if you look at the derivation, you will know how we reach 16 by 27. So please take a look at it. That basically shows you that you cannot capture all the energy available in the windmill. You can only capture available in the wind. You can only capture at most 60% of that energy. But that again is the upper limit, so to speak. It is not really what you will practically accomplish on the ground. You're only going to get maybe 20% of it, and so on. Okay, Himanshu Yadav has a question. Can we reduce the power consumption used by people? Yes, definitely. I think that's a very good point. We have to attack the problem from all ends. So if we only look at say the power consumption of the world is increasing, and how can we produce power to match the power consumption? That's only one way of looking at the problem. We should definitely look at ways in which you can reduce the power consumption by people. Of course, for it to be practical, for it to occur in a very practical manner, you have to find ways of reducing the power consumption without making it inconvenient for the people. That is when it is really successful. Then people really buy that idea. You tell them, if you tell enough people that, here's a way in which you can live, where you live equally comfortably, but you will have a lot less power consumption, then people are more likely to buy the idea. And so that you actually see today with all the LED lighting that has come, that is sort of what has happened. People want a lot of lighting in their house, and mostly it is artificial lighting. Very few buildings are being made with nice designs which enable natural sunlight to come in. So only the older houses used to have that kind of design. Newer buildings are all closed, and then they try to find ways to put internal lighting. So if you look at that situation, The older style bulbs were all 100-watt bulbs and 80-watt bulbs and whatnot. Then even the tube lights have typically been 40 watts and so on. Even the CFL bulbs have been like 20, 30-watt kind of bulbs. But now with the LED lighting that has come, you can actually have very significant lighting brightness in the illumination using bulbs which are just 5 watts, 10 watts, 15 watts. So you have come from something that used to be 100 watts to something that is just 15 or 20 watts. So your power consumption has come down by a factor of 5. You're only consuming 20% of the power you used to consume before, but you're illuminating the house equally well. And the life of that bulb may also be quite high. So that combination works very well. So like that, if you come up with technologies which make the people feel equally convenient or equally comfortable, but the energy consumption is significantly low, then that is very useful. So I will also give you an example, for example, water consumption. So power is just one aspect of it, water consumption. So I have seen this in some places where you have this foot operated tap. So you will, so this indirectly impacts the power consumption because you keep pumping up water to fill up your tank. But this foot operated tap helps you conserve power. It also helps you conserve water. So typically you see if people are brushing their teeth or washing their hand, washing their face, washing vessels. So many times the tap is still running, but you are busy working with the soap. You're applying soap to the vessel or applying soap to your hands or to your face. And because your hands already have the soap, you're not switching off the water. So a fair amount of water just goes down the drain without being used. On the other hand, if you have a foot-operated tap, and there are companies which sell foot-operated taps which can be connected to your regular basin very easily, then it's just like an accelerator or a small pedal which you would use in a vehicle. So you just press it, you get water, you take your foot off the pedal, water stops. So it is multi-purpose. It is hygienic because you're not using your hand. The next person comes, they're only also using their foot. And it doesn't matter, I mean, at any stage of your operation with the vessels or your hand or your face, you can stop the water instantaneously without using your hands. So it is very hygienic. It conserves water in a dramatic manner. If you actually do an analysis of how much water is used while washing a vessel or washing your face, you will find that only a small fraction of it is actually being used for washing your face. Much of it just goes down the drain. So you can control that. It's hygienic. It saves power in 2 ways because you don't need to have this complicated sensor to, in which front of which you have to show your hand for the water to come, and for which you're spending a lot of money setting up the tap. That's usually 5 to 10 times more expensive than your conventional tap. And all the power that is used for pumping that water up is also now eliminated. So you use, just 20% of the water and get all of this done. So there are interesting ways. So LED lights is one, foot-operated tap is another. Like this, you can think of multiple ways in which you can conserve energy and resources while keeping the same comfort in lifestyle. And that is what will really be successful in this context. Okay, so there has been a question on thermal batteries. I need to look up some information on it. I will get back to you on that. I don't have an immediate information on that. I need to look at that. So there's something on pollution from Diwali. Again, I think we need more data for us to make a judgment on how much air conditioners pollute versus festivals pollute, etc. So I'm not sure there's an easy answer for that. Is there a PG course for NCER? If so, please give some names of institutions. Okay, so let me, PG course, I think, for example, there are, I'm sure, pretty sure. For example, there is a energy center in Bombay. So if you, IIT Bombay, so they probably have PG courses specifically on energy. In many of the other institutes, including many of the other IITs, both in chemical engineering, material science, physics, etc., there are I mean, essentially research activities which go on in the area of renewable energy, including mechanical engineering and non-conventional energy kind of activity. And so you can definitely do PG level activity there. Nanda Kumar wants to know how old refrigerators cause harm, consume more electricity. Basically, technology has been improving quite a bit. It's all about how the compressor works, how heat transfer works, how you distribute, how do you take the heat away from the fridge, how do you seal the fridge better so that you don't lose the, don't lose that chillness, or rather you don't allow heat from outside to come in. So in those ways, the refrigerators have vastly improved over the years. So if you look at really old refrigerators, there will be very heavy refrigerators, which will have very relatively less internal space that you can utilize. Today, the modern refrigerators are much lighter. They have much more internal space for the same external space that is available. And basically, the heat transfer is much better, much more efficient between the anything that you keep inside the fridge and what is being pulled away, the heat that is being pulled away. And they have how they manage the vents and that the flow of air within the fridge. All those things matter, and that is how those fridges have become more efficient. Okay, Utsav Bharadwaj has a question on, when we say that a material is transparent to radiation or some parts of solar radiation, then what does it mean? Physically transparent, or it may be opaque, but the radiation will pass through? Okay, so this is a good question to understand what we mean by this idea of transparency. So normally we think of transparency only within the context of visible spectrum. So that is what we are seeing. So therefore, when I just say that something is transparent, you will immediately visualize something like a clear glass. And I say something is totally transparent, you immediately visualize something like clear glass. So you keep the glass, you can see right through. Okay, so that is the idea that when we say transparent. Now, the spectrum of radiation that comes from the sun, or even just the general spectrum that is available to you of all possible radiation, contains a lot of radiation. A very large fraction of that radiation is not in the visible spectrum. So in other words, there's a very large fraction of the radiation that which our eyes anyway don't even see. Okay, so we are not even seeing that radiation. So when I look through a clear piece of glass, and if I keep a pen in front, and I look through a clear piece of glass and I see the pen, I'm only seeing the visible spectrum of that is coming from the pen, that is reflecting off the pen and coming. A lot of other radiation may be coming, which also got reflected from the pen and came through, but my eyes never saw it. Okay, so all that radiation is also always there. So when we say transparent in the more general sense, we tend to think of this kind of clarity of a clear glass, because we are always associating that word transparent with visible spectrum, which our eye sees. But in reality, the spectrum is much larger than the visible spectrum. And so you can have materials which are transparent to other parts of the spectrum. So when I say other parts of the spectrum, you have a lot of wavelengths available. Only a small range of wavelengths is 400 nanometers to 700 nanometers. That is the only set of wavelengths of the electromagnetic spectrum, which is the visible spectrum. You can have less than 400, you can have more than 700, all of which is not in the visible spectrum. So you don't see it. So let me give you a number. Let's say 200 nanometers. So this is electromagnetic radiation of 200 nanometers, which our eye will not see. So if I go into a pitch black room, totally dark room, and you put a source of radiation which puts out this 200 nanometer electromagnetic wave, it will not help me see anything better. You switch on a light, which is now putting radiation between 400 and 700 nanometer, I can see something. I will be able to see the room. If you change the frequency and go past 700 nanometer or go below 400 nanometer, we will not be able to see anything. Basically, the room will be dark. But radiation is there. It's very much there. Okay. So I can think of a material which is transparent to 200 nanometers radiation, which means for 200, if there was an animal which could see 200 nanometers radiation, it will see through this material. So that 200 nanometers will come through it as though it were clear glass, and it will reach that animal's eyes, and that animal would actually be able to see. So if that 200 nanometer radiation were reflecting off the pen, so the same pen is there, the 200 nanometer light falls on the pen, reflects from that, and hits this material, goes through the material, and if there is this animal which can see it, it will actually be able to see the pen. we cannot see it. So for us, if you keep a 200 nanometer radiation there, you keep the pen and you keep this object, which is otherwise opaque. It is not glass. It is some other object. It will just it will come through the object, but our eye will not recognize it. So that's what it means. Okay. Pratibha Singh wants to know if drag type windmill are still in use or completely eradicated. They are not completely eradicated, so they have some applications where they may still be in use. They are not the type of windmill that is used for power generation. So power generation, you don't see the drag type kind of things, primarily for efficiency purposes. Okay, if the water level at various electric generation plants is reduced, how do they affect the production of electricity? So I'm assuming you're talking of hydroelectric power stations. So they need certain minimum amount of water for it to come down that the kinetic, I mean, the potential energy of that water you have to harness. So you need a certain minimum height of water to fully utilize the capability of that power generator. So excuse me. So yes, if you run out of water, you will not be able to generate electricity, or you will be able to generate only very small amounts of electricity. Okay. Ujjwal Singh wants to know, in solar plate collector, can we use steel hollow pipe in place of copper? Yes, you can use steel hollow pipe in place of copper, but it is not. Steel is a poorer conductor of heat compared to copper. So in terms of actual conductivity values, it is less conducting than copper. Therefore, it will not be as effective in transferring the heat. But otherwise, you can use, potentially you can use. So Pratibha Singh wants to know about the concept of two-blade windmill is inefficient. Why? So okay, so I was also looking at the next question. The windmill, see, basically when you have a tower, so this is the tower on top of which this windmill is sitting. So there's a blade on top and there's a blade below. Okay, so it is sitting like that, and the blade is rotating. So one blade on top, one blade below. So the blade on top does not have any obstruction because it sees wind on top and it sees nothing behind. So the wind goes. So that whereas the blade that is at the bottom sees wind in the front, and this tower is blocking. The tower is right behind it. So it does not get as much free flowing breeze as the top blade does. And that is only that instant. Then as it rotates, both of them come off, both of them are off, then it rotates the other way, and then the blade that was at the bottom goes to the top, what is at the top comes to the bottom. So what this means is, and then the conditions are reversed. So now the blade that was originally at the top and is now at the bottom is not going to get as much free flowing air as the top blade is going to get. So what this means is the blades don't face uniform conditions as they rotate. And when one blade is like well exposed to breeze, the other one is shielded from the breeze. So that leads to a kind of cyclic loading. So one blade is heavily loaded, the other blade is unloaded, and then the unloaded blade becomes reloaded with wind pressing against it, etc., and so on. So generally, over a period of time, that's not good for the blades, and that causes a problem. So that is the issue there. Okay, so there's a question on when we say solar cell is itself powering its own self, then what do we mean by that? So I think maybe let me just try to understand what you're saying. Utsav has asked this question, so I'm guessing this you're talking about the forward biasing of the solar cell. So what I meant is that you can take a PN junction and you can connect the P side to the positive of a battery. You can connect the N side to the negative of a battery. Then you have done a forward bias of PN junction. What actually you have done, you have tried to put more negative charges on the N side and pull away negative charges, effectively put more positive charges on the P side. That's basically what you have done. This you have accomplished by keeping a battery external to the solar cell, right? That is external to the PN junction. Now in a solar cell with this PN junction out in the sun, automatically the same situation is coming where you are getting more holes on the P side, more electrons on the N side. So without connecting an external battery, it acts as its own battery and creates the forward bias of the PN junction. So I'm assuming that that's what you're referring to, because we didn't discuss this in class. Maybe that's what you're referring to in your question. Right. What is photocurrent is a question. Photocurrent is basically the current that is being generated by the photons that are falling on the solar panel. Okay, Nandakumar wants to know, is there any technology other than solar panel that can use sunlight to produce energy? So yes, I mean, the three techniques that we talk of, solar thermal, solar photovoltaic, and solar photocatalysis, are all ways in which we are harnessing the solar energy. And therefore, those are the alternatives that you have. The panel is just one option. Okay, Gunasekaran wants to know, is there any fluid whose boiling point is less than 100 degrees Celsius for production of steam to run turbine? So first thing is, the moment you say steam, that is water, and water boils at 100 degrees C at 1 atmosphere. Please remember that it is at 1 atmosphere. So at a different pressure, it will boil at a higher temperature or at a lower temperature. So generally, if you have much lower temperatures, the liquid will boil more easily. Whereas if you put higher temperatures, you're putting at much lower pressures, the liquid will boil more easily. Which means, because it means you're sort of sucking the liquid up, and then it more easily evaporates. If you put more pressure from the top, you're forcing the liquid to stay in the liquid state, so it will boil only at higher temperature, which is basically how your pressure cooker works. Because you're putting that weight on top, and so it has to climb to a slightly higher temperature to boil. So therefore, this idea that some other fluid which is boiling point is less than 100 degrees Celsius will now enable your steam to be generated is not really the correct way to maybe think of it. So we are actually looking at more likely that we are looking at the possibility that you have some other liquid which is actually going to run the turbine, and not water at all. So there are a lot of liquids which boil at temperatures less than 100 degrees C. There are many organic solvents which will evaporate very easily and which can be used to boil and therefore run the turbines. Okay, how does part of this photocurrent get consumed within the solar cell? Yes, that's the same thing as that forward bias that I was talking of. When there is forward bias, some current will get consumed there. Pratibha Singh wants to know about numerical problems that may come on Bernoulli's theorem. That I cannot tell you because that's part of the question paper. So you have to decide what you want to learn. So Abhishek Verma wants to know about methane gas. What are the reasons that lead to Gobar biogas technology failure? I don't know if there's necessarily a failure. You have to look at it this way. There are a lot of competing technologies, and you need some company or industry to actively take up this process of commercializing a technology, and also keeping an eye on the competing technologies and trying to tell the public, tell the government how their technology is cleaner, how their technology is more cost effective. So today the industry cannot take a laid back attitude saying, for a long time in India, we had this thing that we would, let's say, make you also know that, if let's say the automobile industry, because for a long time there was a control on the industry, there were only 1 or 2 cars that people could buy. And then there were no other vehicles available. So then you can sell whatever you want. Those 2 cars can be in any shape. They can be in, any level of efficiency or inefficiency or quality of build or lack of quality of build. People are forced to buy because that's the only 2 things that are available. But then once you open up the market, today you can see that the public, with respect to, let's say, any 2-wheeler you're buying or a 4-wheeler you're buying, there is so much choice. So you're yourselves asking, why should I buy this scooter? Why should I buy that scooter? I want to buy a scooter, but why should I buy your scooter? I can buy that other manufacturer's scooter, which is better. Maybe you want to carry more load in your vehicle, so you need a little heavier duty vehicle. So you have a lot of options available to you. So the industry cannot have a laid-back attitude saying, yeah, I have some product, naturally you will buy it. So it's not going to happen that way. So any technology, so when you have competing technology, like somebody's trying to sell solar panels to you, somebody's trying to sell windmills to you, etc. Everybody has to now be on their toes and try to show you why the windmill is a better deal, why is the solar panel a better deal, why is the biogas a better deal, etc. So you have to package it well, you have to make it more convenient for people to use and so on. So I don't think any one technology is a complete failure. We would have to work with the technology and maybe with the right people working on it or the right mindset with which they work on it, the same technology could be successful. Okay, I think based on what we set out to do today, we've had a fairly good discussion. I'm happy that you could join and you could ask a lot of questions. I think we will close for today. Please keep the discussion forum open for your questions. I'm sure you have more that I may not have answered everything that you have asked here. I've tried to answer most of it. Feel free to send us more questions on the discussion forum. We will certainly address that as we go forward. And potentially we will have yet another live session sometime, maybe closer to the exam. At that point, we will take a look at it. And hopefully we'll have another session like this. So thank you very much. Thanks to all of you. I'm glad that we could catch up today. Okay. I just typing even. I want to type you on. So thank you. We'll catch up another.